I've got to say that I am tremendously impressed by RT Thread, and especially the RT Thread community. I think this is a tribute to the power of the open source philosophy. So moving on, our next presenter is Lance Harvie. Lance is an experienced embedded engineer who is passionate about all things related to embedded systems. He holds a BSc Honours degree in Microelectronics and Information Processing, and the topic of his talk is edge computing use cases. So I'm going to hand this over to Lance.
As you can see from my little slide here, I have been working in the embedded space for quite a number of years, and I've been asked to give a small talk on the future of embedded systems development, I suppose, in the sense of where is this space going in light of all the... Hi folks, Lance from Runtime. As you can see from my little slide here, I have been working in the embedded space for quite a number of years, and I've been asked to give a small talk on the future of embedded systems development, I suppose, in the sense of where is this space going in light of all the changes that are going on in general computing. For instance, artificial intelligence, machine learning. We hear all about that when it comes to the big companies that are working on these big systems. But now machine learning is starting to find its way to the embedded space, particularly on small microcontrollers, and hence TinyML has emerged, where you have the training of the models taking place in the cloud or on more sophisticated computers, and then the results of that model are optimized and then compressed into a small footprint that can then be deployed onto a microcontroller for very narrow use cases. Because machine learning requires quite a lot of compute, it cannot be a general purpose machine learning algorithm. It has to be very specific. So there are absolutely a huge amount of use cases for machine learning at the edge, or TinyML, and I'm going to talk a little bit about that and show you some of the use cases. The jury is still out in relation to how effective machine learning can be from a business perspective. Technologically, absolutely, you get loads of benefits, and I'll explain some of those benefits to you in this little video. However, the jury's still out as far as what is the ROI from a business perspective. Machine learning at the edge still needs very large or a unique use case scenario, which is going to be like a killer app, I guess, for machine learning at the edge. We're not there yet, because what we're seeing is people apply machine learning to all sorts of use cases. However, critical mass has not been achieved yet where there is mass adoption of machine learning, mainly because of the nature of the applications that TinyML has been applied to. So I guess I'm going to talk a little bit about that as well. So a building, you've got heating and lighting, you've got electricity, you've got gas, you've got all of the environmental control things that you can have within buildings. You've got energy saving facilities, automation within a building. So you've got a lot of things that can be automated and can be monitored for efficiency. So machine learning at the edge can be applied across the whole range of different types of functions within a building to give it the smarts, if you like, to operate more efficiently and also to create more conveniency for the occupants of that building. So you've got here improve public safety, which I mentioned earlier, make the buildings smarter or the city smarter, prevent the grid downtime. So grid downtime, it really is, if you lose power in a building, watch your backup. A lot of buildings have generators. It could be a hotel, it could be a residential building, it could be a business building. A lot of these have backup generators, normally fueled by some sort of a diesel engine, which will generate electricity for a certain period of time whilst the grid is being repaired. So these are certain options that people can provide them. Batteries maybe in the future, or some sort of a solar option, some sort of wind option, some of these green options. But I think this is what this is about, and how do you trip these devices before the problem occurs, because what you want is a smooth transition from when there's a blackout to when the power comes on. There should be some predictive analytics that is monitoring these fluctuations in the electricity and the current, and then doing that through the ML model, training that model. It can do more predictive analysis and be able to do that smooth switchover from the grid to the backup power source, and the end users will not even know that there was actually a blackout. That's ultimately what this is trying to achieve here. Then we've got things like the air conditioning, obviously, that's been mentioned here, and also preventive maintenance. Now, when an air conditioning unit fails, you don't want that failure to be there and then you got to deal with it. You want some sort of preventive maintenance where some sort of a system is looking at what's happening as far as anything that may be out of a pattern, and then tripping a sort of a backup system before it actually happens. You got intelligent environmental controls that's been mentioned, smart security cameras, which is obviously things like face detection and so on. This is all part of the security. Of course, this also talks about smart home voice control. I have all of that here in my home. I have Alexa, which I use, and of course we've got Siri, and we got Google Assistant as well. I have my home totally automated, but it's not automated via a server in the cloud. I've actually gone and used open source software using Home Assistant, and everything's locally controlled. So if the internet goes out, the systems still continue to work. But this is an application area also for TinyML to do predictive analysis for users of home automation systems, or those who are vending it. So I think, the idea of programming a smart home system in the old days, and still exists today, is the idea of setting up certain flows, I suppose, if this then that sort of idea, and then, based on a condition, a trigger, something will happen. Well, if we would extend that out and create some sort of a model that actually goes beyond this on and off kind of idea and into the fuzzy logic. Fuzzy logic's been around a while, so basically machine learning is like an extension of fuzzy logic, where it will do some sort of analysis based on multiple parameters to give you a more accurate kind of outcome for your particular environment. Now, a good example of that is the Nest thermostat. Now, what the Nest thermostat does, which is very, very clever, in the first month, what Nest will do, the Nest thermostat will do, it will be looking at all of your heating and cooling habits. So it's going to look at all that, and it's going to create a model uniquely for your home and your patterns, your habits. And then after a month, you don't have to worry about it. It will automatically turn off and on all of your appliances for your heating and cooling once it's learned within a month what your patterns are, what your habits are. And that's really what predictive maintenance is trying to do, and predictive analytics is trying to do, let's say, with smart home technology. And I think that's the future of all of this technology. You're going to see a lot of TinyML applications being deployed into applications like smart homes and intelligent buildings and smart cities. Appliances have been getting smarter and smarter, and so every one of us has a microwave, has an oven, has a washing machine. All of these devices are getting smarter by the day. I have in my home a smart kettle, which is Wi-Fi connected, a smart fan. A lot of these devices are picking up this information. So what do you do with this information? Now, with Samsung and a lot of these vendors, they have screens on fridges. They have the ability to figure out what's in the fridge so they can automatically order for you, which is then connected to an intelligent assistant. This is all part of the evolution of intelligent devices, IoT, I suppose. It is really where the intelligence is with the Internet of Things, is more and more intelligence is kind of shifting towards the edge using technologies like TinyML. So you're going to see a lot more of that. And now health is a big one, right? So health, and I'm sure that you guys are all wearing some sort of a fitness tracker. I certainly do. I've got one of these. This is my fitness tracker. This is not an Apple Watch. As you know, with Apple Watches, they're very much into fitness tracking and so on. I didn't go that path. I went this path because this has a sensor on it, which is a heart rate sensor. It's an all-day heart rate sensor, and this thing has a really long battery life. I can run this for like 5 days without having to charge it. While with the Apple Watch, I'm gonna have to charge it all the time. So this has a lot of analytics. So it's gonna sit in my wrist, and it's going to read my sleep patterns. It's going to basically figure out my sleep patterns. It's going to figure out my heart rate throughout the day. And also it's going to count my steps. So it's a great fitness tracker. And all that information is available in an accompanying app. So this smartphone app, which I have, which accompanies this, just gives me readings of my daily activities, physical activities, my heart rate and so on, and also my current heart rate as well down here, and sleep. This is actually sleep. This kind of blue chart is my sleep patterns, and I've got a rating of 79. I normally have a good rating of around 80, 85, sometimes 90, and this is around 80, which is okay, but it gives you how many hours you were in bed for, how many minutes you had deep sleep, and also your current heart rate, so which is really useful information. So what has this got to do with TinyML? Well, TinyML is going to find its way into applications like this, where the models are going to do more predictive analysis on all of your data. Give you information about when you might become sick, or your body's going to run down based on the analytics that it's finding. And it's going to give you some information next time you log into your app. Say, hey, listen, maybe you should be taking some more vitamins. Maybe you should go and see a doctor. You're about to come down with a cold. So this is very important for things like machine learning at the edge. What I have here, in my case, I have a watch that's connected by low energy Bluetooth, low power Bluetooth to my smartphone. So, that's all you need, really. You don't need it to be sent to the cloud for analysis. It can be done, the analysis can be done on chip in the watch itself and then sent to the actual phone for further analysis, because these days phones are pretty powerful. And then if you want, it can be sent out for further processing to the cloud. And some of these carriers will actually need that information or want that information. So I think we're going to see a lot of that. I think, you can see here, heat exhaustion detection, rural healthcare. So rural healthcare is a very interesting thing, because we have a number of clients that are doing this right now for aged care. They're using machine learning and all of these kinds of IoT devices to monitor people who are living at home on their own. They normally have a tracker on them, and that tracker will be monitoring certain different life signs, and also looking at movement and so on, so that information can be gathered, and there can be predictive analysis on that to figure out if there's a pattern out of sync, and which can then trigger alarms at head office for people to go around and see if they're okay. So that's for aged care, but loads of different applications for rural healthcare as well. Information can be sent remotely to doctors, who can then do remote surgery or remote analysis, remote medicine, if you like. Sleep quality monitoring, I already mentioned that to you earlier. I showed it to you, and that's very important these days. Sleep is critical for one's health. I think a lot of people neglect sleep. I think your body needs sleep. It needs 7 hours minimum. Some people can get away with less. 7 to 8 hours is your average sleep that you need to get every night. That's rested sleep. And if you're not getting that, your body and your mind is going to suffer. So if you've got a device like I have, and a lot of people have these days, that's going to really help you to monitor. Look, if you don't know what's going on outside your body, then you're going to be less aware. See, information feedback loops are very, very useful to figure out where you're at, so you can recalibrate yourself in the world regarding your health and so on. So having that information coming back at you from sensors that are picking up your body signs, your vital body signs, then it's going to allow you to make better decisions, health decisions. There are a lot of companies, certainly that we deal with all the time, some of our clients, they are building these very sophisticated medical devices, and they are all moving in this direction of now taking the information that they're gathering beyond the dashboard from simple graphs, and they're taking that and putting that into machine learning models to get better analysis from the models. So I think this is only going to continue, and I think some of that machine learning algorithms are going to find their way to the edge, to the sensors themselves, so that you get a better distribution of compute power as well. So what is infrastructure? Infrastructure is all the roads and trains and all the stuff, that buildings, everything really that creates our modern day world, transport and so on. Grid power monitoring, we mentioned that a little bit before. This is a little bit of an extension to what we were saying earlier, where you're not just looking at a building, where you're looking at the building power supply to figure out if it's running correctly, but this is now extends it to the power grid, where you can look at the power transmission systems and look for any issues, again based on loads and fluctuating loads and things like that, which are out of the normal bands, the normal operating bands, and give early warning signs for any failure that may come up. Water utility leak detection. So leak detection is a big thing. Now we have some companies actually that we work with in Australia. This is a very good use case for IoT, where huge amounts of water can be saved. Water is expensive in a place like Australia, for instance, where it's a very dry country. So if you're losing water underground because of a leak, then that could be very expensive for a council. So we have a couple of clients that actually have gone and deployed leak detection systems to help councils figure out where the leaks are so they can be fixed quickly. And again, machine learning at the edge can extend that predictability to save water. Audio-based crime monitoring, things like the sound of glass breaking, that can be analyzed. Now in the old days, and it still exists today, there are sensors that you can put onto glass panels so that when the glass breaks, the sensor will get triggered and it will create an alarm. Well, you can extend that even further by analyzing the different sounds that are actually happening, because if a glass panel is broken by, let's say, a ball that's been hit over the fence by some kid playing ball, then it's going to be a different kind of situation than if it was a different scenario where it's been hit by a hammer or some other object. So you can refine the detection process to get a better alarm triggering rather than just your general trigger. So again, these are some of the kind of sort of refined use cases for machine learning at the edge. Intelligent traffic control. Now this is a very good one for any motorist out there, including myself. When you find yourself at a set of traffic lights, there's no traffic either way, there's nothing, but the traffic lights are red because it's a programmed algorithm that is in the traffic light, and that is very simple. It's a delay, it's on a delay, and once that delay expires, that's when the lights will change. Well, what if you could extend that where you're looking at the traffic that is coming back and forth, and if there is no traffic, then you just turn the lights green for the motorists that are actually in a particular lane. That will smooth the flow of traffic. It'll become a more efficient flow of traffic. So that could be a use case for machine learning for intelligent traffic control. I think some people are actually using this and deploying it. Okay, I mentioned smart lights, smart street lights as well. Now, smart street lights is another situation where you got the street lights which are illuminating the roads. So why would you want to have them on if there's no one around? So you have to have sensors to detect people around, and when people are around, you turn them on. So you save energy that way. So that's one of the other use cases for machine learning at the edge. Automated road inspection. Now, this is a very important one as well. How do you figure out there are problems with the road? We are actually working with a company that have deployed such technology. They have a vehicle that basically drives around and has cameras on it which are looking down onto the road surface and figuring out if there are potholes, and then reporting that back, analyzing that information, reporting that back to councils. So again, that's a very, very good way of detecting potholes. Other people have done this through social social means, where you have apps, navigation apps like Waze that will then report back, drivers will report back where the pothole is to other drivers to avoid potholes. But I think this system that I've just talked about, which is using computer vision and machine learning at the edge, that's directly relaying that information back to council. So that's another use case for machine learning at the edge. Now, we mentioned wearables earlier on. Now, the watch is the wearable. It's also a medical device, so that's why I mentioned it's kind of both, really. Wearables are a big thing now. So the wearables now, as you know, with the Apple Watch, there's many, many other specific companies, including the Oura Ring. There's actually a company that creates a ring, just like this ring, but it's a little bit bigger. And inside that ring, there's a battery. There's also huge amount of sensors in there, and what it does, it actually monitors your heart rate and your temperature, body temperature, and all sorts of other things, motion, and it's all very convenient because it's actually in a ring, right, form. So having such a device on your fingers is very good. So the way you charge it is actually they have a sort of like a holder where you slot the ring into it, and it actually charges by capacitive induction, really. So a bit like your iPhone does. And it will just charge the ring automatically. And huge amount of analytics is collected. And there's obviously machine learning. I'm not sure how much machine learning is at the edge for this device, probably none, because all the information is collected and sent back to your phone and then sent to the cloud for analysis. What else can you do with wearables? Well, wearables, they have battery, right? They have to be, you have to have a battery because they're portable. So you can create better interfaces, you can improve the battery life, and you can create privacy and better privacy. So improved battery life is a very good one. Once you have a watch on your wrist, what you want to do is the algorithm should be figuring out over time the movement, your movement. How often do you look at your watch? How often is it by your side? How often does the screen turn on? If you look at all those analytics, you can actually probably create a model that will give you a better way for when you want to turn the screen on and off, and it can predict your motions and maybe be able to sort of reduce your battery life over time. So that's one of the applications for machine learning for battery improvement. And they say reduce power budgets, running efficient algorithms on device without having to send data to the cloud for further analysis. So that's another way. That's basically saying, okay, so that's really using the compute power in the actual device and doing it on device before you send it to the cloud. That's one other area of machine learning, but what I was referring to was also an algorithm that you could use for predictive analysis of the user's movements and be able to manage the battery life that way. The wake word detection. So always on word detection for simple headset commands such as on, off, play, and stop. Yeah, you could do that, with on device, right? Rather than, doing it through your phone, which talks to the cloud, you could actually have the sensing of your voice patterns, the analysis of the audio on chip, and then it will do it on device rather than sending it to the cloud for processing, which there's a delay as well. Volume control using headset tilt. So again, this is looking at the movement of your head and figuring out if you're tilting one way or the other, and through that you can control the volume. So the machine learning algorithm will figure out if you're actually moving your head or not over time. Gesture control. This is a good one, actually. This is a very interesting one. There are radar-based chips now that Google have been building, and some other companies have been building this, pioneering this technology. So it's like contactless gesture control. So really what it's doing is there's a radar field that comes from the chip. It's looking at the area around it, has a certain dimension, has a certain kind of area they can cover. And if you're within that area, it can figure out the object, it can scan the form of the object, make sense of it. It can then figure out if there's some sort of a movement on your hand, and then that can then be translated into a knob that you're turning and so on. So that could be done on chip as well. I'm not sure, that's quite a sophisticated algorithm, but it can be done, I think, with a fairly sophisticated microcontroller. So that's one use case for it. ML powered coaching. This is really talking about things like sensors built into the mat, built into your shoes perhaps, or perhaps built into your smartwatch, which is sensing your body movement and also figuring out where you're at, how much your body's actually working, and then be able to sort of give you customized coaching based on where you're at, where your progress is, where your desired goals are, and then sort of figuring out what you need to do to get from where you are to where you need to go. So that's another use case for machine learning at the edge. Performance analysis, that goes hand in hand with fitness trackers. Again, if you can monitor it, you can change it because it's a feedback loop. If you can look at your performance based on feedback from the sensors in a meaningful way, then you can tweak what you're doing to improve your performance to get to where you need to go. Acoustic event detection. This is an interesting one. I mentioned this example earlier on about sort of monitoring glass breaking and so on. What this is saying is you can narrow down, if you can really narrow down to a particular sound in your environment. So you've got all this noise around you, but you can hone in using machine learning algorithm to pick out a particular sound. Could be a baby crying, glass breaking, whatever. So what it's doing is noise filtering. It's doing sound filtering, noise reduction. It's honing in on a particular sound, and then depending on that sound being present, it will then trigger an alarm. So you can work in noisy environments. Asset tracking is very important, particularly for logistics. This is a great one for supply chains. You're shipping a lot of goods around the world, and a lot of the time users, end users, buyers want to see they want to see where their product is, so they can figure out using machine learning. You can provide interfaces to the end user. I mean, these are fairly common nowadays, where you can track exactly where your product is along its track from the original seller to your house. And so asset tracking is normally done by having some sort of a marker within the product that's actually on its way from the manufacturer to the buyer. So along the way, this marker is being tracked, recorded, and then being highlighted to the end user as to where the product is. So how do you improve that? You can improve that through machine learning algorithms to figure out what is the optimum path for the parcel to go through if you've got multiple paths for it to go through. So that's just one of the examples. But of course, the other one is looking at things like if there's any delays. You can do analytics on that as well, depending on how the product is tracking through the different channels, because sellers may have multiple channels. They may be looking at what's the optimum channel. So using machine learning, you could actually optimize the different flows of your product to the end user using machine learning models. In closing, what I want to say is that I urge all embedded developers, inventors, entrepreneurs in the IoT space, Internet of Things, and also in the machine learning generally. TinyML is a set of tools and libraries for low-powered, low-resource-constrained environments, particularly microcontrollers, where you can deploy very narrow use cases for machine learning at the edge. So I urge everybody to have a look at some of these use cases. Hi folks, Lance from buyers want to see, they want to see where their product is, so they can figure out using machine learning. You can provide interfaces to the end user. I mean, these are fairly common nowadays, where you can track exactly where your product is along its track from the original seller to your house. And so asset tracking is normally done by having some sort of a marker within the product that's actually on its way from the manufacturer to the buyer. So along the way, this marker is being tracked, recorded, and then being highlighted to the end user as to where the product is. So how do you improve that? You can improve that through machine learning algorithms to figure out what is the optimum path for the parcel to go through if you've got multiple paths for it to go through. So that's just one of the examples. But of course, the other one is looking at things like if there's any delays. You can do analytics on that as well, depending on how the product is tracking through the different channels, because sellers may have multiple channels. They may be looking at what's the optimum channel. So using machine learning, you could actually optimize the different flows of your product to the end user using machine learning models. In closing, what I want to say is that I urge all embedded developers, inventors, entrepreneurs in the IoT space, Internet of Things, and also in the machine learning generally. TinyML is a set of tools and libraries for low powered, low resource constrained environments, particularly microcontrollers, where you can deploy very narrow use cases for machine learning at the edge. So I urge everybody to have a look at some of these use cases. And if you already are working on a product, build in the idea of extending your product to include machine learning at the edge. You're going to get a better result. You're going to get more optimization. It's going to be a bit of a mind shift. And I think embedded engineers need to embrace the machine learning environments out there, machine learning at the edge kind of offerings. Toy with these ideas, play with these ideas. So TinyML has their own environment. It's an organization that helps companies. They also have open source libraries for all number of microcontrollers. So I urge engineers to go and have a look and play with this stuff because it's the future. Guys and gals, if you're in embedded systems development, you need to embrace TinyML and machine learning at the edge because it's coming big time. The advantages are too great to ignore this technology. So you have organizations like this, and you have the other organization which I mentioned earlier, which is Edge Impulse. And all of these offerings can sit on top of whatever tool chain you're using, whatever RTOS you're using, whatever development environment you're using. What you need to be thinking about is how do I integrate machine learning into my project? And if you're working on a new project, embedded project, you need to be thinking about that, the design stage. But if you already have an existing project, you need to be thinking, how can I extend that project to include machine learning at the edge to improve the efficiency of my product, to make it more viable, to make it longer lasting, to make it more valuable in the marketplace, to make it more competitive. So this is actually a competitive advantage for those people who adopt and understand and want to run with this technology. I've actually been playing around with this stuff, like I mentioned for you guys earlier. I haven't actually deployed machine learning or ML at the edge on this board, but I'm looking at doing that. I'm actually going to be using an operating system that I'm playing with also called RT Thread. So RT Thread is a very interesting operating system. I think it's a great offering. It's only been around a short time considering what else is out there. It's completely open source. Everyone can use it. It's free to use, free to download, and free to distribute. And it's a really, really good implementation. They've got a great tool chain, compiler, editor, debugger, builder, a linker, everything's there, right? So all you got to do is you just got to try it. I urge you guys to have a look at this. So you've got all these different architectures down at the bottom. So they support a lot of different hardware microcontrollers. And on top of that, obviously they've got all of these different layers of the operating system. And then up here, you've got all these software packages. Now they've got an AI package, which I think you guys should have a look at, and they're looking to extend that as well. They're a very open organization. They want a lot of engagement. They really want people to be part of this ecosystem. What they do is they actually offer it in a kind of like a repository where you can then download and whatever you need. So, down here, they've got AI, they've got IoT. I mentioned IoT. They've got a huge library of IoT offerings here, and this is how it's kind of highlighted, and you can see there's quite a number of pages of this. But let's just go to the AI, and they haven't got a huge number of modules for this for AI, but they've got quite a few that I think you guys could have a look at just to get things off the ground for you to play with. They've got the TensorFlow Lite Micro, I think, which you'll find useful as well. So TinyML and TensorFlow, obviously TensorFlow is also part of the ML offerings out there as well. Whatever is out there for you guys to play with, I urge you to have a go. Have a good look at this. It's coming big time. It's maturing, the environment's maturing, the vendors are maturing. And I think this hooks in very, very well with IoT. It's going to give so much power and value to Internet of Things as we move through time, that I urge all firmware engineers that are out there that are looking to expand their list of skills and experiences to go out and start playing with machine learning at the edge. So guys and gals, I hope you found this useful and interesting and informative. I urge everybody to keep learning, lifelong learning. Keep learning. The landscape, the technology landscape is changing at an incredible rate. We are also going to be attending a trade show at the Embedded Technology Convention in Singapore. It's going to be held in September. We are one of the exhibitors of this trade show, so come and have a look at us, have a chat with us. Down here, you can see us down here. We're in booth 919. Remember that. Please come and say hello. If you're going to be in Singapore in September and you're attending this trade show, this convention, we're going to be there. I'm going to be doing a little presentation there on exactly this topic, and we'd love to see you guys. We'd love to meet you guys. If you have any questions for me, generally hit me up at lance@runtimerec.com, and enjoy the convention, enjoy the conference that you guys are at. I'm looking forward to learning from all the other speakers. Thank you so much for listening to me, and have yourself a great day wherever you are. Thanks, and see you next time. Cheers.